Done? Jessica, done? Have you written the formulas?
1 second, ma'am. Done, ma'am.
Okay. So from what is P? P is the pressure. Formula of pressure is also force upon area. So in place of force upon area, we are writing P. P represents the pressure. So write down where, after writing the formula, write down where P equals to, where P equals to F upon A, where P equals to F upon A, which is the normal pressure, which is the normal pressure. Full stop. Negative sign shows, negative sign shows that the volume, that the volume decreases, that the volume decreases with the increase in stress, that the volume decreases with the increase in stress. Now see, in the formula there is negative sign also, and new thing is P. So P is nothing but the pressure which represent F upon A. In place of F upon A, I am writing P. P represent pressure. Now from where this negative sign is coming? So we are putting negative sign because as we increase the stress, like in the figure, if we increase the force from all the four sides, so what happened? The volume of the solid will be decreases because we are applying the stress from all the direction. So this negative sign represent with increase in stress there is decrease in volume. That is why we are putting negative sign. Clear? Is it clear?
Yes, ma'am.
Okay, write down. In next line, write down the SI unit of bulk modulus. The SI unit of bulk modulus. Now what will be the SI unit? Newton per meter square. Why? Because it is again stress upon strain. Strain is unitless because it's volume upon volume. So the formula will be same for that of the stress. So Newton per meter square or either Pascal, because stress is force upon area which represent pressure and unit of pressure is Pascal. That is why Pascal also. Clear? Jessica, is it clear?
Yes, ma'am. I think my mic isn't working properly today.
Okay, okay, okay. Now next heading, compressibility. 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 For spelling, you can see the screen. Compressibility. Write down the definition. The reciprocal of bulk modulus of a material, the reciprocal of bulk modulus of a material is called its compressibility. Is called its compressibility. Then write down in next line, compressibility equals to 1 upon K. 1 upon K. Compressibility equals to 1 upon K. SI unit will be, what will be the SI unit if it is reciprocal of bulk modulus? So it is, unit will also be the reciprocal of bulk modulus.
Yes, ma'am.
So it is Newton per meter square. So here it will be meter square upon Newton. So I can write Newton inverse meter square. This will be the SI unit. Clear?
Yes, ma'am.
Now see, every material, like suppose we are talking about the metals, aluminum, iron, glass, copper, whatever. Every element, every material have its own Young's modulus, bulk modulus, and modulus of rigidity. The third one. Every material has its own value of bulk modulus, Young's modulus, and the modulus of rigidity. Clear? So it is predefined. So write down here, and there's a table. No need to write that table. In that table, it is shown that the solid are least compressible because they have the maximum bulk modulus. Whenever bulk modulus is maximum, your compressibility will be minimum. Why? Because it is a reciprocal, isn't it? So write down note, in note write down solids are solids are solids are less compressible. Solids are less compressible. Solids are less compressible, while gases are most compressible. While gases are most compressible than solids. Next point, the solids are incompressible because of the solids are incompressible because of tight coupling because of tight coupling between the neighboring atoms because of tight coupling between the neighboring atoms. Full stop. The molecules in liquid are less tightly bound are less tightly bound than in liquids sorry than in solids. The molecules in liquids are less tightly bound than in solids. Full stop. The molecule in gases are the molecules in gases very poorly coupled very poorly coupled with neighboring molecules with neighboring molecules hence more compressible. Written.
Yes, ma'am.
Okay, now what you have written is solids are least compressible and gases are most compressible. Now what is compressible? What is the meaning of what compressibility or compress?
Uh, like to um, basically it's to reduce the space between the molecule in.
Yes, correct. The atoms or the molecules in the material, we are compressing it, we are reducing its size. So it is well known fact that solids are least compressible. Why? Because the interparticle space between the atoms of solid is very less. They are very strongly they are coupled. That is why it is very difficult to compress them. And as compared to liquid and gases, in liquid and gases what happens, the atoms are very loosely packed, so they are more compressible as compared to solid. And gases, you know that in gases there is very all the particles are very far away from each other. The coupling, the attraction between the intermolecular space is very less. Attraction is very less. That is why they are more compressible, because they have the more space between the particles, so they can easily compressed. Clear?
Yes, ma'am.
Now next, third modulus modulus of rigidity. Third type of modulus of rigidity is shear modulus. Shear, shear, shear modulus, or modulus of rigidity. Shear modulus or modulus of rigidity. Now, just like Young's modulus, bulk modulus, this is also the third type of coefficient of elasticity. Modulus of rigidity or shear modulus. Write down the definition. Within the elastic limit, comma, the ratio of tangential stress, to shear strain is called modulus of rigidity. Change the para. As shown in figure, consider a rectangular block. Whose lower face is fixed.
Your voice is low.
Okay, wait. Up to where you have written?
Consider a
Rectangular block whose lower
of
face. Sorry.